Weather predictions are as old as mankind, and why not? They can be crucial to all sorts of planning. If I think that a big storm is coming, should I travel or stay put? If I believe that there will be many days of dry weather, I'll cut hay so that it can dry in the fields. In the distant past, people observed signs in the sky and used aphorisms like red sky at night, sailor's delight as guides. This very saying appears in the Gospel of Matthew, although in a very different context. Although I would argue that weather aphorisms, being rooted in experience, are scientific in a way. At the start of the Industrial Revolution, weather predictions moved into a numerical basis. Instruments like thermometers and barometers came into use. When the air pressure measured on a barometer drops rapidly, it's a sign that a storm is coming. This became expressed as a new aphorism: when the glass gets low, get ready for a blow. Observations by Ben Franklin, as well as others, demonstrated that weather systems, particularly in temperate zones, move from west to east. Franklin himself wanted to observe a lunar eclipse in Philadelphia in 1743. Unfortunately for him, a storm swept through, obscuring the moon. Later on, he learned that people in Boston were able to observe the eclipse with clear skies, and only later did the same storm move through. By the mid-19th century, telegraph networks gave a huge boost to forecasting, particularly in the United States and Great Britain. Weather conditions could be transmitted throughout the countries, greatly improving predictions using the known west to east motion of fronts and storm systems. Then by the late 19th century, forecasts were regularly published in newspapers. Though not always accurate, they were good enough to allow people to plan their daily activities. In the early 20th century, the mathematics describing the dynamics of the atmosphere was reasonably well understood. Then, the idea emerged that weather could be predicted accurately if a set of complex equations describing the conditions over the Earth could be solved. With the development of digital computers in the 1940s, this seemed like a real possibility. But it took until the 1980s before a reliable forecast could be achieved. The computations use a large grid of squares that span the globe and incorporate data from networks of sensors to create the input. From that input, the computers solve the equations describing the motion of air and storms across the grid squares, ultimately generating predictions. Presently, computer-generated forecasts are fairly good, but they sometimes can go wrong. Certainly, they are not accurate beyond 5 days into the future, and you may ask why. It has in large part to do with the nature of the equations. The forces that govern weather and the equations that describe them are what we call non-linear. What does this mean, and why does it imply that we cannot predict weather indefinitely into the future? First off, I assure you that I'm not going to go into any heavy mathematics. This is far beyond the scope of the course. But I want to give you a feel for what I mean by non-linear. Let's first take the example of a microphone connected to an amplifier and then a speaker. Imagine that the sound going into the microphone gets amplified by a factor of 10 by the time it leaves the speaker. If you speak at a volume of 1, in some set of units, the volume coming out of the speaker is 10. If, on the other hand, you speak louder into the microphone at a volume of 2, let's say, 20 comes out. Speak at 3, and 30 comes out, and so forth. If we plotted the sound level out of the speaker versus the level into the microphone, the graph would form a straight line, and the results would be eminently predictable. If, on the other hand, we took the microphone and put it directly in front of the speaker, an entirely different behavior results. Any little noise in the microphone will get amplified and emerge from the speaker. This sound, in turn, will go back into the microphone, get amplified again, and emerge from the speaker again. Pretty soon, a loud screeching noise will emanate from the speaker, which is called feedback. In this case, there is a relationship between the microphone, the speaker, and ambient sounds that are distinctly nonlinear and also quite unpredictable.